Today I'm back on exorcism.org and I'm looking at this exercise specifically, this challenge, grade school. The idea being that if you're given a list of student names and their grades, you should create a roster, right? A list of names based on grade. You should also be able to pull out a specific list of names by grade. So if I only wanted the grade 3 students, I should only get those names. Okay. They also have some very weird rules in here where all students only have one name, right? It's kind of unique. Can't be added to more than one grade or roster. And there's some testing around there that we'll see. I have copied this code over to CodePen and we're going to explore this. The really cool thing that I think is interesting about this challenge is that solving it isn't really that isn't really the interesting part. Okay, the interesting part here is in how we store the data. And what I mean by that is for this, if we just thought about it from the perspective of what they are asking for, then we might look for an object, right? And inside of there, we might have a grade. And inside of there, we might have name and name, right? And then below it, we might have a second grade, which is also has a list of names, okay? So that's one option. Another option could be where we have just the names, right? So maybe we have an object here and we set name equal to grade, and I don't know why it keeps wrapping like that. That's so weird. Name equal to grade, probably because I'm inside of a class. We'll get to that in a second. But we could totally do it this way, right? Where we just have key value pairs and then we'd have to organize it, okay? Still another way that we could do this would be to go all in on our data structures. So we could have an array and then inside of there, we would have an object and that would have name and grade, right? And then down here, we could just paste that in like this, right? So that it looks kind of like a database, right? We could take that even further. So let's just take this all the way to its full conclusion, and we could store it as something that you'd probably see in a NoSQL database where it has a unique key. We do have to switch this. My bad here, but this should actually be an object. And then inside of there, you have a unique key and another unique key and still another unique key, right? And then you would have to pull that information off. These last two are the most flexible in my mind because they allow you to grow with the data. Maybe you want, I don't know, like address formatting because it's a school roster, right? So these allow you to grow into the data. But jumping right into this, we're going to start with this one, and then we're going to explore some of these other ones down here, okay? I want to show what that data looks like. And so I'm going to start out by adding a new method. And this method only really applies to us, right? We aren't going to use it inside of the exorcism challenge itself. We're probably not going to leave it in here if we were actually using this code somewhere. But I want to be able to see the data. So I'm going to set up a getter, and that getter is going to return something. Now, what is that data? And this is something that you don't quite catch on to until you're in the challenge. They don't mention that you should not be able to edit this database, the data outside of this class. And what I mean by that is if we had db equal to our object, because that's what we're going to create here, okay? So if we had db equal to object, and I just return this dot db, which technically won't work because I have these things named the same. But if I was to return this, I could edit that because the object is passed by reference, right? It's not a new object, it's the old object. Any changes inside of here are reflected into this object, possibly polluting anything that I'm doing inside of this class. We don't want that. So we're going to protect it a little bit by starting here, and there will be some other things that we can do. The sharp or pound or octothorpe, whatever you decide you want to call this, the number sign, sets up a private property on this class. Okay, it means that we have to use it everywhere, but to start, now we can't just edit the DB directly. Okay, so that's there. We are going to use this right down here. So console log, just so that we can see the difference, see the magic happen, right? Like that. Now I don't need parentheses because this is a getter. So it acts like a property, even though it's a method, okay? For roster and grade, we absolutely do need those, and we can get into this. Now we want this shape, right? We want to send the name into a specific grade. We should do that when we add the data. So starting right here, we can set up a thing where we go this.db and we add that grade, which I totally forgot to add as an argument. So it is name and grade. That is way down here, right? Name and grade. Okay. So we get that grade and we push. Okay. We push the name. This could fail. And the reason that it could fail is because currently there is no grade on our object, which means that when it tries to get grade, it's going to get undefined. And push is not a method that is on undefined. So we need a little extra work here, okay? And that looks like this. We need to go if, okay, if not this dot sharp db grade, okay? I could have just copy and pasted that all just like this. If we don't have that, then we should set it to an empty array so that we can push into it. Okay, so now we have this safeguard and we could run this. If we do that, we're going to get errors. I don't know why I clicked run because I'm not done yet, but we can start to see the data. Okay, so we have Jeff, we have Paul twice, we have Franklin and Bradley. They aren't sorted, but they are there. We're starting to see stuff. Okay. From here, inside of roster, we can just return this dot db, and down here, we could probably do the same. Okay. Return this dot db grade, because we want to only return the keys for that, or the values for that grade. Okay. If we do this, we run it. Nothing should break this time. We get our data. Okay. Still not sorted. We can quickly do that just by going this dot db dot sort. Okay. We don't need to pass anything inside of here because by default sort goes alphabetically. Okay. So we're going to see that, clear this out, run it really fast, and we should get something that is broken. What? Oh, because I didn't add grade. Racing ahead, doing my thing. Add the grade, clear it out, run it again, just like this. Sorted. B before F, B before F. Brilliant. Okay. There's a problem here, though. We have Paul twice, and remember the rule was that Paul should only show up in one of these classes, not both. Okay. So we need to test something. And what that looks like is we want to do a loop. Okay. This loop is going to get the year of this DB. Okay. So we're going to get for every one of these years, 1, 2, 3, 4. That's the key. We're going to get the values. Okay. And what we're going to do is we're going to go this dot, I don't know why I keep saying dot when I mean sharp, dot sharp db, bit of a mouthful, year. Okay. It's not grade. it's year because we want this value, not this. I changed them so that we wouldn't conflict. Okay. We're going to set that equal to all of this so we can actually copy it right to the end. Dot filter. Okay. And what we're filtering on is now the student, the name inside of that array. Okay. We want that to not be equal to this name. Okay. So student not equal name. And if we've done this right, it means that we have cleared out the name from here, which means that Paul should only show up once. Just like, oh, I have a thing. Where is it hiding? What have I done? Let year in, not of. Of, in. Right. My bad. Run it one more time. Brilliant. Okay. Grade 3 is empty because Paul was in there. We moved him back down to grade 2. We're funny like that. Okay. The reason that it was failing is because of, right? Let year of this .db iterates on an array. So it assumes that this .db is an array. We're in an object, so we need in. Okay. The I is not iterative. Anyway, moving on. We got it. But there's a problem here. And it's not just this empty thing. We could go and clear that out. But it's the fact that every time we add a new name or set up a new name, we replace the loop. Even though we might create a new user down here, we are going through and generating a new array every time, even if we don't find name. Okay, we don't find name. That means that we return everything in the current array as a brand new array, which then gets inserted into this this property, this year, whatever that year is. So we are doing a lot of work here. That makes this a terrible plan. Okay, every time we add a user, we are making huge sweeping changes to the database. I don't like that. Hopefully you don't like that. I think we can do better. Okay. So the first thing that I'm going to do is I'm going to grab all of this. Okay. Copy it, comment it out, and I'm going to paste it underneath this. Okay. So right here, we have that exact same object. Why? Oh yeah, that's okay. Right here, just like that. But now we're going to change it. Okay. We no longer want all of this stuff. Instead, all we want to do is toss that information up to the database. Okay. I don't want to use an object just yet. Instead, I want to play with something called capital M map. And capital M map is kind of like the fancy version of an object. Okay. It allows for unique values. It allows for some iteration because it will actually remember the place of certain keys. So it's like the big brother to object in the same way that capital S set is the big brother to arrays. Okay. So we can do that. Right down here, we actually get this DB again. We're always going to use that. And on capital M map, there is a set property. Set property takes two arguments. The first one is the key. So we want that to be name. And the second one is the value, which is grade. Okay. That's all we're doing here. Everything else we're going to do right up here and try and get this done. I also realized that I haven't secured this value. We're going to do that in a second too. So for roster, for this, we need to do some work. And that looks like this. We're going to get that DB again. And because it's a map, we have access to for each. Okay. For each takes a callback, and it looks exactly like the regular for each. Inside of the documentation, they call it value and key, right? Normally it would be value and index. Index is a key on an array, right? But neither of these names really work. So instead, I think I'm going to go with name for this and grade, right? The grade is a value. The name is the key. We're going to do some stuff here and continue on, do it right, just like this. Great. Now, we want to push into that year again, right? So we need to get that year. Let's do that really fast. Everything by reference here, so we can totally go class roster equals something. Where are we going to get that data from? We haven't figured that out yet. We're going to call it school roster, okay? At least I'm going to call it school roster, and I'm going to peel off the grade on that, okay? This is a variable that we haven't made yet, but we are going to add values to it. So const school roster equals an empty object. Same thing as before. We have this problem where if it doesn't exist, we need to create it. So we can copy and paste this right in here and uncomment it, tidy it up. Brilliant. It even adds some semicolons. I could take it or leave it. But these values here, not the right ones. We can replace this DB for school roster and school roster grade. Excellent. Okay. So we have the grade. Now we need to do all the other stuff. So again, it's kind of this, right? We copy and paste this right up here. Again, it's uncomment it, tidy it. I probably should have just copied all of that. And then grabbing class roster, pasting and pasting. Oh, you know what? I don't need the grade, do I? Because the class roster is the grade. Excellent. And of course, returning school roster. Okay. Now, I did say that we haven't secured this. The fastest way to secure this is just to make a new one. So we could either spread that or do some fanciness. For this, I want to point you to structured clone. Okay. Structured clone will do a deep clone of an object. So we can pass that in. The magic here is that structured clone won't change any of your methods or any of your really fancy stuff. So if you have, I think if you have like sets in there, capital S sets, it doesn't really do stuff with that. But for our very simple structure up here, this will work quite nicely. Okay. We should also move that down here because this is no longer accurate. Our data doesn't look like this anymore. So we need to update this. We can actually replace it with this dot roster, right? So we get the data and then we just get the piece of the data that we need. Now, again, this should be wrapped up. So we're going to do that. Structured clone. Hopefully I spelled it right in both places. And if we run this, excellent. So you'll notice that we get the data. We get this all sorted. We get what appears to be an empty object here, but it's not, because if you look up here, it says object map. Okay. If I go into my dev tools and I look for that map, you'll see that I have key value pairs, key value, key value, key value. So this is just CodePen not being able to display it, but it is working. It's working quite well. Okay. And this is good. We have the data flowing in as an object, key value pairs. We were able to sort it a little bit more efficiently because we probably aren't calling roster every single time. And then we are able to output it. I feel like we could probably do a little bit better on this, maybe with an object, right? So if I copy this whole thing, I'm going to copy the comments too, just so that we have it. Probably should have commented that out just like this, move it down. Okay. And we still want this shape. We still want this shape, but instead of a map feels very heavy to me. Okay. So what if we just used an object, right? We're just going to use that object, which means that when we add, we're going to add the name property to that object, and it's going to be equal to grade. That's the only change there, okay? And then way up here, we need to do something with this database because we need to be able to get those values. And the way that we get those values is with something called object.entries, okay? Object.entries, just like this. And we paste that back in. And obviously it's not going to have a for each. Instead, it's going to have a reduce, okay? The reduce is going to take an accumulator, just like this. I'm not sure why I'm trying to copy and paste all this, but that's okay. So we're going to get the accumulator, and we are also going to get an array, because entries returns an array of arrays, technically tuples, depending on how you pronounce it. And the tuples are a key value pair. So the first array item is the key. The second array item is the value, okay? We can peel those off right away. So we get the key, which is name, and the second one, which is grade. And now we can use that, okay? Before we do that, we should actually set up our accumulator, right? This is a reduce, so we need to do some magic there. It's always going to be an object because that's what we're outputting, okay? Down in here, we're going to do a lot of the same stuff. So that const school roster, just to keep it nice and consistent. Hold on a second. I feel like I got this wrong because I already have school roster. So I totally do. This goes up here. That's what we want. And then down in here, I'm going to set up my statement, okay? We're going to return like this because we should always return something. We always return, in this case, we're always returning an object, okay? So we return the previous accumulator. It's such a mouthful, really, accumulator. And then we want to get our grade, okay? And on our grade, I wrap it in square brackets so that it knows that this is going to be the key, okay? Otherwise, it should be a string, right? But not right now. This is a value, and the square brackets tell the system that whatever the grade is coming from way over here, that's what you're going to use down here, okay? And then we're going to get an array, which is going to be one of two things, okay? So the first is going to be the grade, whatever the grade is inside of the accumulator. If we already have one inside of the accumulator, we want to keep using it, okay? The second, if we don't have a grade already, for instance, if it's the first time doing grade 4, right, we need to set up an empty object. And we can totally do that because we're returning a brand new thing every time, okay? So we either get the data that already exists or we start something new. And then from there, we can add our name and we can sort every single time, okay? At this point, everything else is the same. None of this should really matter. We can get rid of it, hopefully. And if I've done this, it should be, there it is, okay? This time we do get to see the key value pairs because it's just an object. Before it was a map, remember, maps don't display in CodePen, but objects definitely do. And then all this data is exactly the same down here. And of course our grade 5 class, I believe that is, yeah, grade 5. So this is looking really, really good. We can keep going though, and we're going to keep going, okay? So I'm going to grab this again, just the code parts, comment it out, and we're going to go down and look at this code here, okay? So right here, I'm going to paste that in, move the database around, and we want an array, okay? We want an array. It's going to have objects in it. So again, we go down here. This is going to be dot push again, Okay, we're going to push into it, and we're going to push the name and the grade. Okay. Now the problem here is that with this one, we need to find if that name already exists. And if it's inside of an object, we need to do a little bit of digging. Okay. We can use find for that. So we can go const existing student equals what? This db, just like this, dot find. Okay. Because it's an array, we can just go to it directly and we find that student, which is student.name equals name. Okay. So the name is going to equal name. If we find it, we get it here, and now we can use it. If we don't get it, for the record, if we don't get it, we get undefined. Okay. So we can go here and test for existing student. And if we have it, then we can update it. Because it's all passing by reference, we can totally just latch onto it. Okay. Existing student dot grade equals grade. Okay. Else all of this good stuff. Bump it up just like this, move it in, clean it up. Excellent. Okay. So now we're getting that data in a different sort of way. We also need to clean it out here because it's an array. We can no longer do entries. Instead, we are just going to do, the other way, db.reduce. But the key here is that we're no longer getting an array of names, right? We're no longer getting an array of key values. Instead, we're getting an object with two things, okay? Just like this. So object with name and grade. Everything else in here should be the same. That's really all we needed to change here, okay? Hopefully, if I've done this right, I can, not that. Let's, where did my console go? There it is. Clear it, run it. And it is done. Let's try it one more time just to be sure. Okay. So we have these objects in here, which each have a name and a grade. And then down here, we still have these 6 students, okay? 1, 3, and 2, all nicely sorted. Nothing has really changed. Everything is looking really sharp, right? This is probably my preferred method because this is how data is going to come out of the database. So we would be doing something like this. But I do want to go with one more, okay? And that one more is what I'm going to call the Firebase model, okay? So if I copy this, I'm going to bring it right down. Firebase likes to store stuff in these key value pairs. So it'll create a unique ID, and then it will have the object. And we totally can do this too, okay? This is not an issue at all. We do need to dig a little bit. So instead of pushing, we're going to get a unique ID, okay? So we're going to set up an ID. It's going to be equal to whatever this is. Get rid of the brackets. Perfect, okay? We're going to come back to that ID in a second. Up here, because it's key value pairs, we need to dig a little bit here too, okay? And we do that with object.values. Object.values will do exactly that. It will get the values, ignoring the keys. We don't really care about the keys. In fact, we need to do this twice, once here and once right here, okay? So based on that, we have everything that we need except for this ID. Now, a lot of projects will import a package that will generate a UUID or some sort of a custom hash, but JavaScript actually has this built in. So we can go const ID equals window.crypto like this dot random, spell it right, UUID, all capitalized, just like that. So we get the data, we put it in there, and then we pull the data out. We don't really care about the values. We just want to see the magic happen so that we can do it. This also needs to be an object. So I might have, I almost missed that. But hopefully, let's take a look. Excellent. And you'll see that if we scroll up here, we have unique IDs with our object, but we're still peeling off that data and sorting it in the way that we want. Okay. So that's a bunch of just really solid ways to get this done. I do want to leave you with one last method, and it doesn't quite line up. Actually, it does. Sorry. I don't know why I was thinking that, because I did find a solution. But I do want to leave you with one final method. And that looks like this. I'm going to go and copy this out. Okay. And I'm going to paste it. Oh, I'm going to comment that out first. Let's make sure that we aren't breaking stuff, Dave. There we go. And I'm going to paste it down here. Good. Okay. Now, I want to look at this right here. Okay. Just the roster. Everything else is the same. Nothing about this is going to change except for the roster. So inside of the object interface, we have something new. We have something called group by. Okay. And what we can do is we can group by a specific property. So I'm going to comment this out just to hide it for a second. And then I'm going to do the magic. So right here, I'm going to set a let, because we're going to do two things here. So school roster equals object.values db. Okay. We still want that, but we want to button it up. We want to wrap it up just like this in object.groupBy, capital B on that by. Okay. The first argument is the array of objects that we want. It has to be an array of objects. I haven't been able to get this to work with just an array of values. An array of objects is where we have to live. Okay. So we get this. We pass in the student, and we want to get the student according to its name, right? According to their name, sorry. Student.name. Grade. Sorry, we want grade. And the reason that we want grade is because it's going to sort them into their categories. Right now, we have this data where it's the IDs and the objects, but we want it to be grouped by whatever that grade is. Okay. So right here, we can actually see this in a single step. It's going to look just like this. And you'll see that it does kind of work. We're losing our sort, but it's sending through the whole object, and I don't really want that. So the next step is to do some work here. Okay. We need a for loop. Type it right. Let grade in. Okay. Because again, it's an object. School roster. Brilliant. Talking too much here, so losing my train of thought. But inside of school roster, so for that school roster grade, we want to do a thing. Okay. What we want to do is we want to, on the one side, we want to sort, and on the other, we want to map it. Okay. So we're going to get school roster grade dot map. Dot map, just like this. And we're going to go student name. Okay. Just like the, come on. So close to the end of this video. Don't screw up now, Dave. Okay. Student name. We only care about the student name. So we can test this. If we run it again, run it, we get unexpected token. Map. Student name. What am I missing? I'm missing. I've done something funny. Hold on. I know what I did. it's an arrow function here, but it's not an arrow function here. That's just silliness. So there we go. They aren't in order, right? We can do that by going .sort. Again, we don't need anything in there because it's alphabetical. We can clean out all of this other stuff just like this. Clear it one more time and run it. Okay. And we get exactly what we expected right from the beginning. This sounds like a really solid way to do it, especially when you consider that at some point you're probably going to want to go to a database anyway. Okay. So having it as a series of values, right? Where did that go? Oh, it's hiding. There it is. Okay. As a series of unique keys with an object, you can grow into this. So if you needed that address, right, you could totally add it. Not a problem. And it would be very easy, very fast, especially if you're using NoSQL, right, or Firebase. This is kind of what Firebase does for you. It generates that ID for you and then tucks the object in behind it. Okay. So really solid example. And we saw lots of stuff today, right? We started out trying to make it like they wanted in the tests, right? That's the grades with the names. We found that it's messy because every time we add a name, we are changing the whole database. There's just no way around it. Okay. We could try and surgically remove a single key, but we still have to loop through every grade to make sure that we got all the different names. So that's a little bit messy. Then we went to a map. I'm not convinced about capital M map, but still trying to play with it, still trying to get a feel for it. We can definitely do that. We set it up. We can for each on there. We can do some other stuff too. Very handy that way. And the cool thing again about map is that it will retain its order. So you can iterate through this in a very consistent way. We moved that into an object so that we could see the magic a little bit better, because objects and maps, they're kind of the same thing, right? At this basic level, they are functionally the same. We aren't leveraging a lot of what map gives us. So using an object here is probably a good choice. We extended on that by going even deeper, switching back to an array with objects in it, which changed how we go through some of this, but also allowed us a little bit of flexibility, right? We had to do a little bit of extra down here. We are not changing everything in the database, only the value we need to, or adding a brand new value, right? This is good. This is a good thing. And then, of course, going all the way to something that you'd see in NoSQL or Firebase, where we have those unique keys. We don't care about those unique keys. We never actually use them, but we might get them, right? If you actually store this, you might get that back and you might have to work around it. So object.values. And then, of course, finishing one more time with a little bit of newness. Group by, it's not everywhere, and it is not the most intuitive thing to use, but in time, I feel like it could be the way, right? We can definitely sort it, and then we had to map through to clean up the data, right? If we were just passing the data down, we would be done in a single line, right? So easy that way. And that's it. We did a ton of stuff today, and it was all focused on data structures. A lot of this stuff in here, inside of the methods, not a lot of magic there, right? That's all documented stuff. But figuring out how to store your data and what the best way to store your data is, that's where the magic of this challenge happens. Did you pick a different way? I would love to hear about it. Share it in the comments. Let's keep that conversation going. Otherwise, I will see you in the next one.